Welcome to this explainer. Today, we are tackling a massive, literally planetary scale thought experiment. So, what if every single human on Earth jumped at the exact same time? I know, it sounds totally absurd, but the reality behind it is grounded completely in physics and logistics. So, let's dive right in and explore what would actually happen to our planet. All right, I want you to really try to picture this scenario with me. Imagine every single person currently living on Earth, basically all of us, gathering together. We'd have to stand shoulder to shoulder, packed incredibly closely in one massive, sprawling crowd. We're talking young, old, people from every single continent on the globe, all united for one incredibly bizarre, singular purpose. We're all just standing there waiting for the signal. The sheer visual of that many people in one place is staggering, but the real question we're focusing on is the physical action. What if we all jumped? The tension in this giant continent sized crowd would be absolute madness, right? Imagine the global countdown echoing across the gathered masses. 3, prepare to jump. 2, bend your knees. 1, launch at once. Every single person sends their entire body weight off the surface of the Earth at the exact same millisecond. No stragglers, no early jumpers, absolute perfect synchronization. So, what actually happens at zero? Section 1, the giant jump, calculating the mass of humanity. Well, the magic number here is 62, specifically 62 kilograms, or about 137 pounds. According to the data, this is the weight of the average human being. Now, obviously, this varies wildly from person to person. We've got babies, we've got adults, we have totally different body types. But when we average it all out across the entire human population, 62 kilograms is the baseline we're working with for our massive planetary jump. Now we have to apply sheer scale to that average weight. We take those 62 kilograms and multiply it by 8 billion. Because, yeah, over 8 billion people currently inhabit the Earth. When you actually do that math, you get a genuinely enormous, almost incomprehensible amount of mass. We are talking about hundreds of billions of kilograms of human weight, all acting as one singular, coordinated physical force. And that brings us to this incredible reality. For one brief, suspended moment in time, all humans would be airborne. Every single ounce of that massive combined weight we just calculated leaves the ground simultaneously. For a fraction of a second, the Earth is entirely devoid of human footsteps. It's wild to think about. But you know the rule, what goes up must come down. And when that unimaginable amount of mass comes crashing back down to the surface, well, it sounds like enough physical power to fundamentally shake the entire planet. Let's see if that's actually true. Section 2, did the Earth move? The physics check. Technically speaking, the answer is yes. This perfectly illustrates a fundamental rule of our universe, Sir Isaac Newton's third law of motion. Every action has an equal and opposite reaction. It basically means that forces always come in pairs. You literally cannot touch something without it touching you back, and you can't push something without it pushing back against you. So here is exactly how this plays out in our crazy scenario. On one hand, we have billions of humans pushing down. As our 8 billion pairs of legs push off the ground to jump, we exert a tremendous amount of downward force on the Earth's crust. But because forces come in pairs, the Earth responds by moving in the exact opposite direction. So yes, by jumping, we actually push the planet away from us. But before you go thinking we've altered the course of human history and sent Earth hurtling into the sun, the movement of the Earth would be less than the width of a single atom. Seriously, while the planet does technically move, the movement is so incredibly, unfathomably small that no human, and honestly, no standard scientific instrument, could ever truly notice it. Why? Because the Earth is just astronomically bigger and more massive than all of us combined. We are essentially a tiny speck of dust pushing against a giant boulder. Section 3, the Earthquake Myth, Debunking Surface Tremors. Now, it's a very logical question to ask. Would this cause giant earthquakes? A lot of people naturally assume that the synchronized landing of 8 billion people would crack the Earth's crust, tear up roads, and send these massive apocalyptic shockwaves rippling across the globe. It sounds terrifying for sure, but is it scientifically accurate? Actually, it wouldn't cause an earthquake at all. Real earthquakes are the release of enormous amounts of energy stored deep, deep underground. They're caused by massive tectonic plates grinding together over thousands of years beneath the Earth's surface, building up intense friction until they suddenly slip. It's a deeply geological process involving forces that completely dwarf anything happening up here on the surface. To put that into perspective, we know that a stadium full of cheering, jumping sports fans can sometimes create very small, localized vibrations that actually get picked up by seismographs. But even scaling that up to 8 billion people, it produces a tiny, tiny fraction of the energy needed for a real quake. Contrast that surface impact with the massive energy from natural geological processes beneath the crust. The planet experiences natural forces every single day that are infinitely stronger than the combined landing impact of the entire human race. We just simply don't have the power to break the Earth's crust. Section 4: The logistical disaster, the real catastrophe. Because getting every human in one location would be nearly impossible. Just think about it. We would have to somehow migrate 8 billion people to a single localized landmass. The sheer physical space required just for everyone to stand shoulder to shoulder would be enormous. We're talking an area about the size of a small American state or a European country. But honestly, physical space is just the very beginning of the problem. This is where the whole scenario completely falls apart. All of our vital infrastructure systems would collapse. Our cities would empty out. Our roads would gridlock instantly. I mean, how do you provide drinking water for 8 billion people all crammed into one place? You can't. The water supplies would fail immediately. Food systems would totally collapse because, well, no one is out there farming. And you can't transport that much food to a single location anyway. The entire global transportation grid, planes, trains, ships, would just buckle under the impossible demand of moving the entire human population. Which leads perfectly to this quote summarizing the research: the logistics would be the true disaster. Organizing the event would be far, far harder than the jump itself. In reality, the attempt to gather everyone together would result in the collapse of modern society, widespread starvation, and total systemic failure long before the countdown to the big jump even began. The preparation is way deadlier than the experiment itself. Section 5: Humanity's True Scale, the final verdict. So, if everyone magically appeared in one place and jumped, the definitive results are clear. We'd get a tiny Earth movement, literally less than an atom wide. We would see absolutely no giant earthquakes. There would be zero change to the planet's orbit around the sun. And, assuming we bypass the whole logistical nightmare, there would be no physics based global catastrophe. The Earth would just keep spinning exactly as it did before we all jumped. And that leaves us with this final, rather humbling realization. This massive jump is really just proving how incredibly small humans are compared to the size of our planet. We build massive cities, we change the atmosphere, and we often feel like we're the undisputed masters of the Earth. But when it comes down to raw mass and physical force, 8 billion of us giving it everything we've got doesn't even make the Earth flinch. It puts our place in the physical universe into a brilliant, crystal clear perspective. Sometimes the craziest, most seemingly absurd questions lead us to the most fascinating science and a much better understanding of our world. We've seen today that we definitely can't jump the Earth out of orbit, but the thought process to get there, that's incredibly fun. So I'll leave you with this to chew on. If you could ask one what if question about Earth, what would it be? Think about it, stay curious, and keep exploring the incredible science of the planet we call home. Thank you so much for joining me for this explainer.